Okay, welcome to the TypeScript workshop. Checking code is JavaScript not equals Java. So check in at members.acmucsd.com for your points. And if you want to follow along with the slides, if I'm going too fast, going too slow, or you just want to look at these on your own time, then feel free to go to this link here, acmurl.com/TypeScript-slides. Anyway, TypeScript is basically JavaScript that doesn't suck. So first, we have to learn what JavaScript is. So for people who don't know anything about JavaScript, because there definitely are people like that out there, no experience with JavaScript. Well, it's not actually that bad. It's a pretty interesting language. So what is JavaScript? Well, first of all, it's not Java. It has nothing to do with Java. I don't know why they call it JavaScript. Yeah, it's kind of ridiculous, but has nothing to do with Java. It's a web client language originally. So it makes things interactive on websites. So for example, when you click a button or something, that's going to trigger some JavaScript code to run in the background and do something like increase a counter or, you know, call a function or make a request to some backend server, stuff like that. Yes, it did only get its name because, yeah, Java was a pretty popular language at the time. I think it was like in the 90s. So, yeah. So anyway, now it's also used server-side and natively. So with technology like Node.js and now Deno, Electron apps for desktop and React Native for mobile, you can now run JavaScript outside of the browser. So it's really gone from being just this like exclusively in browser language to now being used in things like servers, systems, and native applications. So it's really gone of like a huge transformation, I guess, over the course of its life. And it's an interpreted language. So that means that it's not compiled. So everything you write is going to get read and run at runtime. So this is basically kind of like Python. In fact, it is exactly like Python because Python is also interpreted. It's imperative because it gets run like line by line, essentially, telling like things what to do. That's kind of reminiscent of C. But it also does have elements of object-oriented programming and functional programming. So JavaScript is kind of a mess. We won't go into the details of this last bullet point today. But if you do want to learn more, there's stuff out there, right? There's classes, objects and all that. Okay, so let's just get started with basic syntax. So this is just gonna be a really quick crash course. It's not like comprehensive by any means. So if you want to actually learn JavaScript, you should probably try writing your own website for a bit or watching some of our Hack School recordings from last quarter. Anyway, so there's 3 ways to declare variables in JavaScript, var, let, and const. Originally, var was just the only way of doing it, but recently let and const became a thing. So var declares a global variable that can be accessed anywhere. And this is not really that good because if you declare a variable inside of a function, you expect to not be able to use it outside of the function. But JavaScript doesn't guarantee that. You can use this variable anywhere you want. So to get around that, we have let. And this can be only accessed within the block scope. So this is block scope. This is an interesting thing. It's not unique to JavaScript. There's a few languages that also do this. But if you also think that this can be an if statement or a function or like a for loop or something, basically you can't use this variable outside. So in this example here, console.log local var, This is outside of the block scope, so it won't work. It's going to throw an error. Also, you notice semicolons are optional, but they are recommended. So basically, you can choose to omit these, but in a lot of styling guides and just for writing clean code in general, you should put these because I think there's some weird edge cases where like not having the semicolon breaks things. Anyway, so next up is const. So this is just constants. So you can essentially assign it a value, but that value can't be changed. So it's pretty self-explanatory, I think. If you're interested, there's this website JS console that just lets you type JavaScript stuff in to experiment with. But you can also just inspect any page and go to the console, at least in Chrome. Oh, looks like there's an issue here. And you can write JavaScript commands right here. So hello world. And it'll run the command. You can define variables, do all sorts of things here. It's really, it's a really nice way to test out like random things. Oh yeah, TwoSum. We'll get to that later. But yeah, if you just want to test out random JavaScript code, then this is a pretty nice way of doing it without having to do any kind of setup beforehand. Okay, so next up, there's different types of variables. We'll get more into types, obviously, with TypeScript. So there's undefined, Boolean, number, string, big int, and symbol. And then there's other more advanced types like objects, arrays, and functions, which we'll talk about later. But the thing about JavaScript is that variables are not restricted to be a single type. So you can do crap like this where you define a variable as false and then you define it as 5 and it still works, right? This is perfectly fine because foo doesn't have a type. So you can define it to be whatever you want. And here we define it to be a function. So this is the arrow notation. And this is now a function we can call and it still works. And this leads to some really, really weird stuff, which we'll talk about later. But yeah, these are the basic types. Boolean is true, false. Number is just integers and decimals. String is a string of characters, so a sequence of characters, text. Big int is basically for integers that don't fit in the number category, that are too big. And symbol is basically a unique identifier for things. Honestly, you really only need to worry about like these 4. Big int and symbol is they're not really used that much. All right. So next up, we have objects. So JS objects are definitely not Java objects. So they're a little bit simpler. They're basically, you can think of these more like hash maps. If you don't know what hash maps are, they're basically a collection of key value pairs that you can access in a big O of one time, so constant time. So here's an example here. We define a Pokemon to be a set of these attributes. So name is the key, value is Pikachu. So we can access Pokemon bracket name or Pokemon dot name, and that'll give us Pikachu. And here we can, I just showed that you can have different fields, and these fields can be of any type. So here I have a few strings, I have a number here, and objects themselves can be nested. So in this evolution field, we have another object, and then this is another set of key value pairs. So this is an interesting part of JavaScript, right? You can define essentially these structures, and these structures can look like whatever you want them to be. And you can nest these like infinitely if you wanted to. All right. So next up, basic logic. So this stuff is pretty much identical to C and Java, and use else and else if and else to handle different branches of logic. This is pretty simple, right? If, and then whatever condition here, is true, then do something. If this is not true, it's going to check if this condition is true. And if it is, it's going to do something else. And then if none of these are true in the chain, if we have multiple of these, then it's going to just run this in the else statement. So if you've done like any kind of programming, this should be pretty familiar to you, hopefully. If not, that's fine. Yeah, you're here to learn. And then there's 3 different flavors of for loops. So you have the classic C style for loop. So the syntax might look a little weird if you've never seen it before, but basically you're initializing a variable I to be 0. You're letting this loop run until this condition is false. So while this condition is true. And then for each step, you're going to do this, which is this here. So plus plus just means to increment. It's like a shorthand way of writing it. You could write I plus equals 1 or I equals I plus 1. They all do the same thing. And basically, it's going to run whatever code is in here. In this case, 4 times. It's going to go from 0, 1, 2, 3. And then once it gets to 4, it's going to fail this check and then go out. Next up, you have these different types of for loops. So a for in loop loops through the keys or indices of a list or an array or object. And there's no guarantee that the item's in order. So if you want that, you have to use a for of loop, which essentially loops through the values. And it goes in order. I always forget. I always get these mixed up. So to be honest, I don't have these memorized. I just Google it every time I need to use something like this. There's also the interesting for each function, which we won't go into today. I guess I could, because like I think it's pretty cool. So this is pretty common. Let me just clear the console first. So if you have like an array of like things, let's just do like 3, 4, 5. Right, we have our array here. If you do array for each, you can pass in a function, and then you can do things with each element. So basically, it loops through each element that gets passed in as the argument here. Yeah, so this just looped through everything and printed it out. Pretty simple. So this is an example of functional programming in JavaScript. So invoking functions on things. Yeah, I think it's pretty cool. So next up, we have while and do while loops. Again, this is very similar to C and Java. So while condition, basically we run whatever code is in here until this condition is false. So while this condition is true, we run this code. Do while is basically the same thing, except that we run the code at least once. Yeah. Difference is kind of subtle. Theoretically, if you copied this code inside this block and pasted it up here, it would do the same thing. So yeah, pretty simple so far. Hope everyone's following along. I do know that a lot of people have JavaScript experience, just writing web apps and hackathons or whatever. So, and a lot of this translates, very easily from other languages. So next up here, functions. So you might have seen me do that earlier. So there's 3 different ways to declare, and they're generally interchangeable. I say generally because there's definitely some edge cases, like involving the keyword this, that make these not identical. But for the most part, you can treat these as if they were the same. So here I defined, 3 different ways of defining the function. So this is like a named function. This is like the classic C style, Java style that you might be accustomed to. Yeah, and then the return keyword just returns whatever. You don't have to have return functions. You don't have to return things. Here, this is an anonymous function. So this is the arrow notation that I used earlier. So the arguments are passed in here, and then we have an arrow, which is equal and then greater than. And then you can just write code in here inside this block. Yeah, and then this is an alternative way to declare it. This is a mistake. I just realized there's no arrow here. That was very bad of me. I'll change it afterwards, after this workshop is over. So it would just be function xy, and then you do the curly brace. Don't put the arrow here. This is bad. I'm very sorry. Okay, so real quick, just as a check to apply our knowledge, let's do two-sum. Let's do LeetCode. We all know software engineers just sit around and do LeetCode problems. They don't write actual code. So we're just going to do exactly that. So anyway, two-sum. I'm just going to do the two for loops. Honestly, there's like the hash map solution. I guess I could go over that too. Let's see if I can do this based off of memory. Like I feel really bad if I mess this up. All right, so nums is an array, target is a number, right? So what we're gonna do is we're just gonna do this the classic way, for let I equal 0. I'm actually kind of nervous right now if I'm gonna mess this up. Nums.length. So length is a property of the array nums. LeetCode in JS. Yeah, I actually do a lot of my LeetCode problems in JavaScript or TypeScript, just because I think I'm like easily like the most fluent in that language. All right, so we're gonna start this loop J as I plus 1 because we're trying to find two distinct numbers, right, that add up to be target. Oh yeah, I gotta explain the problem because I guess some people might not know this. So given an array of integers nums and an integer target, return the indices of two numbers such that they add up to target. So basically we're just looking through the array and finding two numbers that add up to the number we desire. And we assume that each input has exactly one solution. So we assume that there is an answer already. So it makes sense that we're gonna loop through the whole array and then this is basically like 2 pointers kind of, but not really. Yeah, and then we're gonna start this because they can't have the same element twice. So there's no point in starting J to be equal to I. Anyway, let's keep going. Nums.length, J++. And then, let's see. So if they are equal, I'm just gonna showcase some more features of JS. So here we're just gonna declare an empty array. So arrays are not fixed size in JavaScript. You can add elements to them. They're kind of like array lists or linked lists. So if nums I equals nums j, right here I use the triple equals instead of double equals. Triple equals is a stricter form of equal. It checks for equality in both value and type. This is important because sometimes you might get different values that are somehow equal even though they're different types. So triple equals just prevents weird stuff like that. Then answers.push. So push is a function that we're calling on the array. We're just going to push I and j. This is not the best way of doing it, not the most efficient or anything, but this is just to showcase like various features of the language. Return answer. Is that right? I hope I'm right. What? Excuse me? Oh, right, I'm dumb. This is a mistake. Plus, there we go. I just blanked out. All right, I totally know how to code. Excuse me? Oh, answers. I'm just gonna delete the S here. Okay. This is embarrassing. I'm failing it too some. All right, yeah, this is good enough. I mean, 34%, you know, that's like a failing grade, but it's not 0%. We're not the slowest implementation out there. So I feel good about ourselves. Yeah. I don't want to think too hard about the hash map implementation because there is a way of doing this in O of n time. But that's not the point of this workshop, so we're just going to move on. I don't want to make more mistakes. So let's get into the problems of JS. So, all these things we talked about, right? Types just changing, objects being any shape, like what could go wrong? I don't know. So weakly typed means that anything is possible, right? So it's completely okay to reassign a variable as completely different type. Objects can have any structure, and this structure can change anytime, right? So if you let an object be of this shape or something, you can redefine that object later on, and nothing's stopping you, right? Unless it's a const. Also, type coercion. So if the types are wrong, JS will try to do the conversion itself to make it work, and you can get some really weird things. So JS fuck is an extreme example of this that essentially abuses type coercion to be able to write JavaScript in in just 6 characters. So, and here I have this chart of the different type equalities, I guess, using double equals instead of triple equals. So, right, you see like 1 is equal to true, right? Yeah, and like 0, false, stuff like that. And these are just different forms of like truthy and falsy values that have really weird equivalences. I actually did a workshop last year with Kyle about some of the weird stuff about JavaScript. I think the URL is acmurl.com/JS sucks. So if you want to look at the slides for that, that's a pretty fun workshop, I think. So yeah, so here's an JS fuck, as I mentioned before. This is hello world. And if you like run this, it actually runs. So if I take this, I straight up copy this code. Let me just clear my console. If I paste this code in, I click, like, it runs. Like, why? Yeah, this was the origin of Hishan's hyena. That was a great workshop. Be sure to check out the slides on that because that was pretty fun. But yeah, this code runs natively in JavaScript without any modifications at all. I don't think that's right for a language to be able to like do stuff like this, but whatever. Yeah, we love JavaScript. We love to hate it, but we appreciate it for the dumb things it does. So anyway, enter TypeScript. So what the heck is TypeScript? Well, it's JavaScript, but with static types. What do you know? So it's a strict superset of JS. So you can write JavaScript code in TypeScript and it'll still run. So the types are actually optional, but it's essentially compiled into JavaScript and then is run by the browser. So basically, with this compiled type feature, this turns TypeScript from an interpreted language into a compiled language that gets compiled into JavaScript, and that gets interpreted by the browser. So it's slightly different. So with the use of static types, we have type safety for everything. So we know exactly what goes in and out of your functions, exactly what type each variable is, and this allows us to catch bugs before they show up in runtime. So sometimes you might run into bugs that essentially deal with types being wrong. Like you expect a variable to be a string and then it ends up being a number or something weird like that. So TypeScript allows you to essentially enforce these restrictions and avoid these weird bugs, right? Like you don't want to deploy your website and then lose millions of dollars for your company when you deploy it and just catch the error when you could just catch it in compile time. So yeah, next up is smart code completion. So because you know exactly how your objects are structured, things like VS Code, IDs like VS Code, WebStorm, you can essentially have smarter code completion, right? Because it knows like which like properties are in your object. And there's newer JS features in older browsers. So JavaScript is a constantly changing language. They're constantly adding new things, like new notation and all that. So, and a lot of browsers haven't caught up to that, which is unfortunate. But with TypeScript, essentially this compiles your code into any version of JavaScript. So you can still use the new features of JavaScript and TypeScript on older browsers. So if people are still using Internet Explorer 6 from like 10 plus years ago, your code will probably still run on that. No guarantees. I mean, I don't know if it really works, but like just on older browsers in general, right? Maybe not as old as IE6. So anyway, let's get to this setup. So this is only if you want to compile TypeScript locally. This is optional for the workshop because we're just going to be focusing on the language itself. So first you need to install Node and NPM right here. I highly recommend if you're doing any web development at all to just download this anyway because it'll be so useful. Node is the runtime for JavaScript, so it lets you run JavaScript code server side. So it's very useful for making servers and APIs. And NPM is a package manager, so it contains the whole like a large ecosystem of available JavaScript packages. So, oh shit. Okay. So real quick, since we have time, I'm just going kind of slowly. So if you want code to tell you that an object is even, right, you can get that code. It's very nice. What about Yarn? So Yarn is essentially just a better implementation of NPM. I'm talking about NPM, the actual like package registry. Yarn is just a different way of downloading these packages and managing these packages. So yeah, I highly recommend Yarn actually. But for now, I don't want to confuse people, so just use NPM for now. I think is even depends on is odd. So yeah, so it basically checks if a number is odd and then returns the opposite. I think is odd depends on is number. Yeah. So this is it's a check of number, like the thing is a number first before checking it is odd. Oh, this is great. All right. Anyway, back on topic. So if you want to install TypeScript, npm install -g TypeScript. So npm is the command. Install means like, to install something. -g means globally. So it's going to install this globally for your whole system. So if you don't use -g, it's just going to install it in the current directory. So if you have an npm package or project, and you don't want TypeScript, to be used everywhere, then this is what you'd use it for if you don't include the -g. And to compile a .ts file, that's the file extension for TypeScript. npx, tsc, and then the file name. So this is pretty basic. You don't have to worry about this for this workshop. This is just for if you want to get this set up. Alternatively, just use the TS playground right here. So this is the official TypeScript playground sandbox that you could use. What's nice is that you can see exactly what gets compiled. So the stuff you write here gets compiled directly into this. And you can run it and export it and do whatever you want. So I think for just learning the language, this is a great place to get started, right? You can just mess around and do whatever you want and see exactly what your code turns into. So yeah, this workshop here is really just to get familiar with the language itself. So we're not too worried about the different types of tooling available, to your TypeScript developer. But to continue on that, so you have a file called tsconfig.json, and this is used to specify files to compile and different compiler option. So if you run the tsc command, it'll look at this file to know exactly what to do. This is an example I copied from the TypeScript website. So compiler options, so this tells you like what features you want to have included. And then include and exclude. So include is just the files that you actually want to be compiled. In this case, we're just looking at everything inside of the src directory. And exclude is just stuff that you don't want compiled. So node modules, for those of you who don't know, is just a huge folder that contains all of the dependencies that you installed. So anything you do with npm install is going to end up in node modules. And you really don't want to compile all of that, right? Because it's already done for you. Most of it is already in JavaScript. It's already built. So just doing that again is just a huge waste of time. And I'm pretty sure it's going to break stuff. So having this in the exclude is what allows you to ignore it. It's kind of like git ignore, but for TypeScript. But again, all this is optional for this workshop specifically. This is just for your reference if you want to include TypeScript in your projects. And typically you would use some kind of build system. You wouldn't just directly use the tsc command. Yeah, you'd use some kind of build system to actually compile your code and run it. Okay, so let's just move on then with basic types. So types are declared with a colon after the variable name. So here we have foo, and this is a string, and we define it as hello world. Bar is a string or a number. So using this, this is called a union. So using this, I think the pipe character is what it's called, basically lets you say that, okay, this variable can be a string or a number. So we still have some flexibility, right? So if we don't know what a type is, we can do stuff like this. So here's just a list of basic or primitive types. This isn't a comprehensive list, but this is just the most used. So any, this is the special type that just means that the variable can be any type. So this basically tells the compiler to, oh, just treat this like a regular JavaScript variable that you can change and do whatever. Unknown is a little bit different in that it's used if you don't know the type at compile time, but not for you to like change the type of stuff. Yeah. Boolean, true, false, pretty simple. String is just any sequence of characters, so text. And number is just any number. It can be integer or float. So yeah, these are the basic types that you'll be using. Anyway, here's some more advanced types. These are like larger structures within TypeScript. So arrays lets you declare the type and the bracket. So here is let nums colon number and then bracket. So this is specifying an array of numbers, essentially. Tuples are kind of similar, but they're just fixed length arrays with known types. So if you know that, okay, this is an event, right? Let's say you have an event where you have the name of the event and then the number of like points you get on the portal or something, right? So string, number. So you know the types of the elements in the array, and it's a fixed number of elements. So you do something like this. So enums, this is a fixed set of possible values. So for example, the different ACM communities, right? Hack, innovate, cyber design. And you can define, a variable to be a type community. And then define it as an element of this. This is just used if you have different options to pick from. All right. So next up is objects. So we can still use the object type to define anything that's not a primitive type. So you can do stuff like this, but you can change the structure of it, right? Because you can change the structure of it because this is still an object, this is still an object, so this is still legit. So this doesn't really fix the issue that we faced before, right? Where objects can change structure and look like whatever they want to be. So there's a better way of doing this, which is interfaces. So these are kind of like Java interfaces if you're used to object-oriented programming, but they're just a little simpler. So you essentially get to define the name and types of properties in your object. So this is an example here where we have an interface ACM member. So this is like defining a new type. I guess you can think of this like a struct in C if you're used to that, but this is just defining the structure of your object. So you want ACM members to have a name, they have points, and you want to know if they like to code. And community, so this is an optional property. So not every ACM member is part of a community, right? Some are just part of general ACM. So having this question mark here specifies that, yes, this is an optional property. So if I were to define a different variable, I don't necessarily need to include this property here. So this is an example. Yeah, it just has to follow this structure. Okay, next up we have functions. So we can specify the types of the parameters and the return type. And there's another type that I forgot to mention before, which is void. This is used for if the function doesn't return anything. So this essentially lets you know what exactly comes in and out of your functions, right? So for example, we have this function here, classes, fail classes. So this isn't going to return anything, right? We just pass in the classes that we want to fail, and the function is just going to make you fail them, and then it doesn't need to return anything. So we're good there. And then there's another function, is even. So this is the most efficient way of doing is even, obviously. You notice this syntax is kind of weird. So we let is even, colon, and then we define the type of the function here. So this is using arrow notation. We define, okay, this is a function that takes in a number and it returns a Boolean. And then this function, this doesn't actually define the function, right? This just defines the type. So now we have to say, okay, this function actually equals this. So it's going to take in a number and it's going to do this with the number. So this is how you do is even, right? You loop through every possible integer that number could be and check it. So yeah, if you ever get this question in an interview, just do stuff like this. It'll sure to get you hired. Oh yeah, so Jaden's addition function also uses this trick. Basically, it just loops through every possible set of two numbers and checks and returns the value. It's the most efficient solution. Like there's no other way of doing it. This is the best way. It's so big brain. Yeah, I'm sorry. I'm not going to write the rest. That would take too long, unfortunately. But trust me, this function works if I were to write it all out. Anyway, so let's just get to the second part of this, which is leak coding in TypeScript. So we're just going to try to write ToSum in TypeScript. And I can maybe try to do more leak code problems because this workshop was a little shorter than I expected. We still have like over an hour left, so we could kind of mess around. Anyway, oh, I gotta think for a bit. So copy and paste the JS and add any to everything. Yeah, you could do that. Let's just go and do that. So that's actually like a way of doing TypeScript. Actually, is you write your code in Java. Oh how do I undo? Okay, Vim shortcuts sometimes mess me up. So let's just paste this code here. I could just copy the inside. Anyway. So like this runs. You can run this technically and it would work. If you want to be precise, you can use the any. So this is showing that TypeScript is truly a superset of JavaScript, right? But in this case, we want to be specific to actually take advantage. So this is a number array. We have to define this as a number. And same with J. J is also a number. And so this works, right? This returns a number array, so answer is the same type. It takes in these values. So this theoretically should work. Oh, this is actually faster than our JavaScript solution. I don't know how, but yeah, the same code just works better. I guess this, 100% proves that TypeScript is just better, right? Anyway, since we have a lot of time, let's try to write the constant time solution, or not the constant time, the linear time solution. So I'm trying not to click on the solution tab. So if I remember, I think this involves a hash map of some sort. So this is a map. We're just going to use any for now. It's easier to. Map B is any number. Right, and then I think we have to loop through nums, if I recall. Let's use our for each notation. So anyway, see nums for each number, we're going to assign, I think it's just this, if I recall. And then we're going to do let target num for nums for each. We're just going to loop through this again, I think. Target num equal number minus target. Or is it target minus number? Target minus number. Someone please tell me if I'm doing this wrong, because I have no idea what I'm doing right now. I'm so bad at LeetCode. So we're just going to check if, I think we could just check if map exists. So if map target num and target num is not equal to no. no, we need the index. Oops. So I think we can grab the index. Current value index, yeah. It's okay to Google things. Target num, let's see. I think we need to assign the index here. I believe we return just an array of J and map. I don't know if this is going to work. It's neither void nor, oh, right. So we got to specify the types of this. Oh, okay, I see. I see the problem. Oop. 0 and 7. Oh, right. This is map. Target num because we want the index. I swear I'm not usually this bad at coding. What the? Oh, right. We want to break out of the loop. So I guess we gotta do this loop, I guess. There's probably a big brain way of doing it otherwise, but I'm not big brain enough. That here. Okay, that should fix it. This is just part of the debugging process, I guess. Yes, this is the life of what the. Excuse me? Oh, right. We don't want these to be the same index. J is our index. This is very sad. Ah, yes, beautiful. This is actually slower. Okay, this is technically linear time. I'm just gonna roll with it. This took too long. Yeah, if you have a better solution, just go do it, please. But yeah, this is just to show some of the basic features of TypeScript. So defining different types and knowing like what comes in and out of our functions. I use the any type here because I was too lazy to like figure out what type this is. That's, I guess, one of the downsides of TypeScript is sometimes you have really weird types that take just way too long to actually type out. So you might use any, or just let it implicitly define the type or infer the type. So yeah, hopefully that's some use to you. So we'll just go over real quick the applications of TypeScript. So what can you actually do? So this is just different examples of code bases and things that you can do with TypeScript. So this is a client-side example. So the ACM static template, and this uses React with TypeScript. It lets you know the exact type of each prop of each component, right? So that's pretty useful, I think. My mistake. Okay. So if we actually look at this code here, we can see like, wow, all these so organized. So an example here would be like landing card. If you don't know React, that's fine. Just attempt to follow along. So not landing card, sorry, event card. This is a good example because this shows you like what happens. So we define a type here. This could be an interface too, as the props. So we know exactly what props get put in, and exactly like what type of thing this is. This is a better example, actually. I think team card. So this is an interface props, and it has these properties to it. So a picture URL, name of the member, the role. Yeah, and this is defining essentially, okay, this team card here is a React functional component that takes in props as the actual like type of prop. And then it defines the things here, which this has to match up with whatever interface you have here. And this just lets you know, okay, exactly what gets passed in. Pretty simple. So yeah, if you want to look at this code base, link is right here. So TypeScript is pretty useful when dealing with React because just because you have all these components flying around and like different types of props going in, it's very nice to be able to know exactly what properties you want to be able to pass. And server side. So there's a package called TS node, and this allows you to compile and run TypeScript from the command line. So this is basically just Node, but with TypeScript, kind of self-explanatory. But yeah, you can run scripts here. You can also just type in the command and it'll just directly run the REPL. So you can type in TypeScript commands, kind of like JavaScript, and just run those directly. So this is another useful tool, I guess, if you want to test out like your code that you're running. And if you just want to build Node applications with TypeScript, this is also very useful. And also Express Generator TypeScript. So if you're working on hackathon projects or just writing a backend API in general, and you want some kind of framework or scaffolding to go with it, then this leverages Express, which is a backend framework for writing APIs, and generates a template in TypeScript. And in terms of backend, how could this be useful is that you might have different types of data coming in, right? So you might want to pass in a JSON, right, to take in a query or something. And you want to know exactly what fields are in that query and exactly what you're returning to the user. So if you have, for example, like a React TypeScript app client that's sending and receiving data to some server, right? It's good to know exactly what data you're sending and what data you're getting back, and exactly like what structures and what that looks like. So that's just an example of what you could do server side with it. So this workshop won't necessarily cover this because, Node is kind of outside the scope of this. If you want to learn more about Node and API development in general with JavaScript, just check out our Hack School videos. I think they're a pretty interesting resource. Or just work on a project, build it out yourself. All right, so that's pretty much the conclusion of this workshop. We actually finished pretty early. I didn't expect that. So I probably could have gone more in depth. But yeah, so if you want more resources, so I recommend the TypeScript Handbook. This is the official documentation for TypeScript. And reading through this, you can get much more information about TypeScript, way more in depth than what I went into here. I just didn't want to like overload information because a lot of this is just not used super often. Right, there's some really weird edge cases. But for example, literal types. So this is if you have a fixed set of values, kind of like an enum almost, that you want this to be. So the type easing is essentially, okay, it can be one of these three values. And you'll see this in things like CSS with React Native. If you're styling something, typically you only have a fixed set of values that you can pass in. Union, so I briefly mentioned this. Yeah, it's just or. And then intersection is a slightly more interesting type that is a way of combining different types. But yeah, anyways, yeah, if you want more information, just check out this resource. All right, that concludes this workshop. So thank you everyone for coming. We still have 8 people left, so that's good. Not everyone left when they saw my really bad leak coding skills. Thank you all for coming. Hope you learned something new and interesting from this. I'll play some lo-fi music just to end this out. Lo-fi.